Tissue engineering aims to fabricate functional tissues for applications in regenerative medicines and drug testing. More recently, 3D printing has shown great promises in tissue fabrication with a structural control from micro to macro scale by using a layer by layer approach. So, today we are going to focus on a case study which talks about the key cognitive structure and technical challenges which the research team is facing in the process of bioprinting. Furthermore, we will also try to find out the importance of spatial reasoning, problem solving, and innovation in overcoming the challenges that the team is facing these days. And this case study will bring a thought about an advancement and the process which is involved in bioprinting, which is going to impact the future of tissue engineering and organ transplantation. So, for doing this case study, you have to go with a design thinking method where you wanted to find the empathy part of where exactly the problem lies, followed by the definition that is about how the problem statement is made. And for the problem statement which is defined, you need to create a solution that comes under ideation. In the first case study, we talked about the process and the bioprinting techniques. Here in the case 2, we are going to focus on the bioink. So we need to consider a case of a biomedical company is in which the process of developing a new type of bioink designed to enhance the viability and functionality of printed cartilage tissue. So the key is cartilage tissue here. So you're going to focus only on that particular part where the bioink becomes the most important one and supporting the cell growth, which maintains the structural integrity of the printed tissue and allows the successful integration with the surrounding tissue post implantation. Most of the cases that we see is all about the post implantation because the biocompatibility plays a vital role in deciding the successful rate of any of the tissue engineering methods. So, followed by, you need to discuss the primary challenges in formulating a bioink for cartilage tissue bioprinting, where you have to focus on the material properties, cell compatibility, and tissue functionality. Likewise, in the case 1, you need to go with design thinking method to solve this case. So I have created a video which tells more in a depth of a manner about the bioprinting process for making the case study to solve the case study easy one.
Imagine a printer that uses living cells instead of ink. This is what bioprinting is. It's like three-dimensional printing, but instead of plastic, it builds tissues and organs using cells. This technology has the potential to revolutionize medicine. It could help people who need organ transplants or create new tissues to repair injuries. Bioprinting is a complex process. It involves creating a blueprint of the organ or tissue we want to build. Then we use a special printer to layer living cells onto a scaffold. This scaffold acts as a support structure for the cells to grow and multiply. The first step in bioprinting is to create a bioink. This ink is made of living cells and a gel-like material that provides nutrients. The cells can be from the patient, which reduces the risk of rejection. Scientists then use a three-dimensional model of the organ or tissue to guide the printer. The printer deposits the bioink layer by layer, just like a regular three-dimensional printer. These layers are very thin, often just a single cell thick. As more layers are added, they fuse together to form the desired shape. This process can take hours or even days, depending on the complexity of the structure. Bioprinting is still in its early stages. However, it has already shown great promise in several areas. One area is in drug development. Bioprinted tissues can be used to test new drugs and therapies in a more accurate and efficient way. Another exciting application is in organ transplantation. The shortage of organ donors is a major problem worldwide. Bioprinting could one day create organs on demand, saving countless lives. While we are not there yet, researchers have already successfully bioprinted skin, cartilage, and even parts of organs like the heart and liver. Although bioprinting holds immense potential, there are still many challenges to overcome. One of the biggest challenges is creating complex organs with a functioning vascular system. Blood vessels are essential for delivering oxygen and nutrients to cells. Without them, bioprinted tissues and organs cannot survive. Another challenge is the cost and complexity of the technology. Bioprinting requires specialized equipment and highly trained personnel. This makes it difficult to scale up production and make it affordable for everyone. Despite these challenges, the future of bioprinting looks bright. As technology advances and costs decrease, bioprinting has the potential to transform medicine and improve the lives of millions around the world.
Bio-ink, the ink of life. Bioprinting is like three-dimensional printing but for living tissues. It uses a special ink called bio-ink. Bio-ink is a mixture of living cells and materials that support them. This ink is used to create structures that can grow into real tissues. Bioprinting holds immense potential for medicine. It allows us to create tissues and organs in the lab. These tissues can be used for transplants, drug testing, and studying diseases. Bio-ink is the key ingredient that makes all this possible. Cartilage is a strong and flexible tissue found in our joints, ears, and nose. It acts like a cushion and helps our joints move smoothly. However, cartilage is prone to damage from injury or diseases like osteoarthritis. Damaged cartilage doesn't heal well on its own. This leads to pain, stiffness, and reduced mobility. Bioprinting cartilage offers a promising solution. We could create new cartilage to replace the damaged tissue. Creating bio-ink for cartilage comes with unique challenges. Cartilage has a complex structure with different types of cells and a strong but flexible matrix. One challenge is finding the right type of cells to use in the bio-ink. The cells need to be able to grow and form the different components of cartilage. Another challenge is creating a bio-ink with the right properties. It needs to be strong enough to hold its shape, but also flexible enough to mimic real cartilage. Scientists are actively working to overcome these challenges. They are exploring new biomaterials that can better mimic the properties of cartilage. They are also developing new techniques to control the way cells grow and organize within the bio-ink. Progress is being made in developing bio-inks that can create cartilage with properties very close to natural tissue. However, further research is crucial to ensure the long-term success and safety of bioprinted cartilage. Overcoming these challenges will revolutionize how we treat cartilage injuries and diseases, improving the lives of countless individuals.